I see the comments and requests and I will act on them. Please remember to follow Geography World channel on Instagram and Facebook using the link shown on the screen. Please remember to like, share with your friends, and subscribe. For persons wishing to contact me privately, you may email me at geographyworld100@gmail.com. The link will be posted below. Welcome back to Geography World channel. For this video, I'll be looking at the May-June 2016 Cape Unit 1 Paper 2. So we're going to look at question 4 for this video. So let me scroll down to question 4. Now question 4, it looks at module 2, and module 2 is the one that looks at the hydrological cycle, rivers, the coast, and the limestone environment. So question 4, it illustrates it shows an illustration of the hydrological cycle, and we're to answer the questions that follow. Part 1 asks us to identify the processes labeled A, C, F, and H. Let's look at the illustration. So A is here, and A is showing evaporation. C is in the clouds, and this is showing condensation. F is here, right here, and it is showing through flow, and H is down here, and this is showing groundwater flow or base flow. Part 2 to the question asks us to briefly describe the 4 processes that were identified. So let's go. So A was evaporation, and evaporation is the process when moisture changes from liquid to gas. So the water is being evaporated from the water bodies here, and it's being converted into gas, and the gas is known as water vapor. C, which is here, we have condensation taking place, and this is the process when moisture changes from a gaseous state into a liquid state in the atmosphere as clouds. So water vapor now is being converted from the gaseous state to a liquid state in the clouds. All right, we have through flow for F, which is here. And this is the downward or lateral movement of water through the soil under gravity. So the water is moving laterally under gravity. And then H is groundwater flow or base flow. And this is where water flows through the rock layers parallel to the surface. So the water is flowing parallel to the surface. So once you have answered the questions correctly here, 12 marks should be yours. Part B asks us to select one of the following coastal landform and explain how marine processes influence its formation. All right, so I'm going to go through all 3, but you're to only select one and basically explain how marine processes influence its formation. I'm going to show you a picture. So let's start with the wave-cut platform. And let me zoom in a bit. Alright, so the wave-cut platform is formed when the sea wall attacks the base of the cliffs. Well, so the sea wave, attacks the base of the cliff between the high and the low water mark. Now, a wave-cut notch is formed by erosional processes such as abrasion and hydraulic action. Now, the wave-cut notch is a dent in the cliff, usually at the level of high tide. Now, as the base of the cliff is eroded, the notch increases in size. Thus, the cliff becomes unstable and it collapses, leaving to the retreat of a cliff face. Now, the backwash will carry away the eroded material and it will leave behind a wave-cut platform. Now, the section that you're seeing here is the wave-cut platform. All of this section here is the wave-cut platform. So many years ago, this area was actually a cliff, but because of erosion taking place, the base of the cliff was eroded and it made it very unstable. So the cliff eventually collapsed to leave behind the wave-cut platform. So a stock is an erosional feature that is commonly found on a headland. Now, what happens is that the waves attack the headland and they create cracks in them. Now, this is an example. So you have the waves attacking the headland, creating cracks. So the cracks, they get bigger, right? So once the cracks widen, they basically widen due to hydraulic action and abrasions. So as the wave continues to grind at the cracks, it begins to open up to form a cave. So this is the cave here. Now the cave becomes large enough and eventually breaks through the headland. So this is the cave. This was the cave, and it actually broke through the headland to form what we call a natural arc. Now the base of the arc continues to become wider through further erosion until its roof becomes too heavy and collapses into the sea. So the roof of the arc collapses here, right? So once it collapses here, it leaves behind a tall rock known as a stalk, right? So this here is the stalk, and you know that the stalk will continue to erode to form what is known as a stump. And this stalk is just an isolated column of rock. Alright, so the Cascade Foreland is a triangular extension of the shoreline. Now it forms when waves approach the coastline at an angle, and this causes the movement of sand or sediment in the water to move in the same direction towards the shore. Now this can cause a buildup of material that may rise above the water surface and grow to become triangle in shape. So it's just some sediments basically building up over time to basically create the base here. So the sediments, once they are deposited at an angle, they stay there and they build up to basically forming something looking close to a triangular enclosed bay. So that's the Cascade Foreland. Alright, so let's look at question C. Question C asks us to discuss two theories that have been used to explain the formation of coral reefs. Now, based on your studies, you should have been exposed to the upliftment and subsidence theory as well as the glacier control theory by Doyle. Now, let me tell you about the upliftment and the subsidence theory. Now, Charles Darwin argued that the growth of coral reef began with the building of a fringe reef around an extinct volcanic island. So the volcanic island was, you had an active volcano, and then it became extinct, and then right around the volcano, that's where we had a fringing reef starting to grow. Now, after the volcano begins to sink, it starts to sink lower into the sea, and the corals grow upward to ensure continued access to sunlight. So while the inner side is submerged, the submerged area between the island and the coral rocks, there'll be a lagoon. So the lagoon will form, good, and then it will basically develop a barrier reef. So because of this extinct volcano is sinking, you have the corals just fighting to stay above so that they can get enough sunlight. So between the extinct volcano and the corals, you have a small lagoon forming, and this is where we will have a barrier reef. Now, as the volcanic island continues to sink, an atoll will form. So the atoll will form when the volcano has sunken completely to live in an enclosed lagoon, and the reef is around the lagoon. All right, now Dana, she agreed with Darwin's theory. However, she suggested that sections of the atoll may be wider than the rest. So she's saying that the atoll would not be the same size and length. You have sections that would be wider, and she believes that the shape was basically a result of the action of wind and wave. So she believes that wind and wave basically helped to shape the atoll, right? Now, as it relates to the glacier control theory of Doyle, her theory suggests that yes, it began with the fringe reef. So she's saying that during the ice age, so he's saying that during the ice age, sea levels were lowered. Now, the part of the reef that remained above water was eroded by subaerial forces, and at the end of the ice age, sea levels rose and corals began to grow once more. So this time they grew on a flat surface. Now this occurred repeatedly, leading to the formation of several platforms and terraces. For a question like this, you just need to know the difference between the upliftment and the subsidence theory, as well as the glacier control theory. The upliftment theory is pretty easy and straightforward. It's just that for the glacier control theory, you might have to do some more reading. I'll place in the description below a link that you can go to get some further information. Question 5 shows us a river floodplain, and we're to answer the questions that follow. Now we're to identify the features labeled B, D, E, and F. Now B is located here, and B is a levee, and the levee is just a raised river bank. D is located here, and that's an oxbow lake. E is located here, and that's the bluff, and we know that the bluff is a steep bank or cliff that is formed by river erosion on the outside of a meander. And F, which is located here, is a river cliff. Now we know that as the river meanders, the outside banks of the meanders are undercutted, creating a river cliff. So when the water in the channel comes and approaches the meander, because of the bend in the river, the meander here, it will not just flow straight through it. What will happen is that the water will crash in the meander here, the bank here, and undercutting will take place, basically form the river cliff. Part B asks us to describe 4 main characteristics of limestone. Now you're to describe 4 main characteristics of limestone. Some of the characteristics of limestone that you can look at are the chemical composition. And remember that limestone have more than 80% calcium carbonate. We can look at the hardness of the limestone. Remember that limestone, they're relatively soft, but they vary with age. You can look at the texture of the limestone. So for example, Barbados corals, they have a coarse texture, while shallow marine coral, water corals in Bahamas, they basically have a finer texture. You can look at the structure of the limestone. You can look at the distinct cracks and joints, their layers along bedding planes, and their coarse textures with large pores. You can look at the permeability of the limestone. They are very permeable, meaning they allow water to pass through them easily. And remember that they have a light color. So once you're able to explain any 4 characteristics of limestone, you should be able to get your 8 marks. Next, part C asks that we explain how waterfalls may develop in a river channel. Let me show you a picture of a waterfall. Now, in areas of alternating layers of hard and soft rocks, the soft rocks will be easily eroded. Now, waterfalls are formed when a river flows over a layer of hard rock. Now, the hard rock is resistant and erodes more slowly than the soft rock below it. So the hard rock forms a steep edge over which the water falls. Gradually, the water digs out a deep pool at the base called a plunge pool. So if you're looking at this, so the river is flowing over a layer of hard and soft rock. So what will happen is that the soft rock is easily eroded. So what will happen is that it will start to undercut or erode the soft rock. And then the hard rock, because it is harder to erode, it will leave like a ledge and the water will flow over. So once the water flow over, it will fall down into the soft rock, which will continue to dig to form what we call a plunge pool. Over time, the hard rock will eventually be, parts of the hard rock will eventually be eroded, and the waterfall will retreat upstream. Let's get back to the question. Part D asks that we explain 1 way in which each of the following factors may influence the cross profile of a river channel. Now let us look at physical. Now the cross profile of a river is from bank to bank. So let's look at some of the physical factors that may affect the bank to bank outlook of the river, the cross profile. So we can look at the velocity or the speed of the flow, and this will basically influence the shape and the rate of erosion. right? So depending on how fast the water in the channel is flowing, it will determine the rate of erosion, how fast or how slow erosion is taking place, thus basically influencing the shape of the channel. You look at the volume of water in the channel. If the more water that is in the channel, the higher the velocity of the river. The lower the lower the volume of the water, the slower the rate of erosion. You can look at also the river load and the river load and the type of rock and size. So if you have a lot of boulders in the river, it could mean that erosion would be more effective. And if you have a lot more pebbles, it could mean that the rate of erosion will slow down. So thus the cross profile of the river will be affected by the type of river load and the size. Let's just look at the human. Deforestation. If we have deforestation taking place, this can affect the cross profile of the river. If we have mining for sand taking place, this is where you're removing sand, which in turn could basically allow the banks of the river to become loose or easier to be eroded. So the banks of the river could easily be widened because of deforestation and the mining for sand. Urbanization and agriculture could also play a key role in shaping the cross profile of the river.
We are at the end of this video. Thank you for watching, and please remember to like, share, subscribe, and turn on your post notification bell in order to receive more videos like these. Leave comments below suggesting topics that you would want me to present on. In the comment section below, comment the name of your school and the territory for a shout out in my next video. Until then, bye!